Okay. So next thing I'm going to do a new script, right? So once I have that data dictionary, I could just keep going in this file. But every time I want to run something or troubleshoot, I have to go back and work through all the files and rebuild that dictionary. So at the end of this script, the script will only be for processing and building dictionary. I'm going to output this dictionary as a pickle. And now I'm going to start a new script, and this script will be for building the actual graph. And the first thing I'm going to do in that script is re-import my dictionary. Alright, so this is the flip side of the pickle library. The first thing I'm going to do is set my working directory again. It's going to be the same directory. I'm going to import the pickle library. And I'm going to re-specify my dictionary variable, right? So in this script, this dictionary doesn't exist yet. But I'm going to load it from that file, and I'm going to set it to that same variable. All right, so now my POID dictionary that I built previously is going to come from this file. So I'm going to call the pickle library .load is the opposite of dump. Okay, load will bring back the data from your file. And here I just want to tell it where the file is. So I'm going to call the open file function, working directory. And the name of that file I set, I specified it here. Right, POID dictionary.p. I'm going to open it as a read binary. So I wrote the file, now I'm reading back. This is the exact same thing as opening any file, but instead of reading text data from it, I'm letting pickle read the data as a binary format. And it's going to actually reconstruct this whole dictionary for me. Just to make sure that works, I'm just going to print the length of that dictionary. Alright, see, this is a lot faster, right? So we're not looking at the whole data file. We're not having to load individual zip files and text files. We're just taking this very minimal representation, and now we have our dictionary with our 12,000 restaurants. If we want to double check again, we can ask for one of these, and now we have this. This was really cool, right? Like, you can bring back this data anytime. It's already organized in this very kind of accessible format. So once I bring back the dictionary, I can start using it and parsing through the dictionary to build my graph representation. And my graph is going to basically look like this. So I'm going to specify a new dictionary. It's the same thing as before. This is now a new dictionary. It's going to contain the matches. This is like a kind of representation of the graph. It's an empty dictionary. And here I want, again, a key for each location. And that key will reference a value, which will be another dictionary, which will contain all of the other locations that location matches, right? So what we're going to do is look through the dictionary, look through all the user IDs, and whenever there's a match between two users, like the same users in both places, then we're going to store in a separate dictionary that relationship. Okay, so I'm just going to set up this double looping structure. I'm going to look at the check-ins, the users of every place, and then I'm going to look at the check-ins of every other place, and I'm going to see if there's any connections between users. Okay, so first I'm going to iterate through every key in this dictionary. Oops. Okay, so for key in dictionary keys, it's going to iterate through every entry, and key is going to be set to the current place ID. I'm going to create a variable called current. I'm going to take the dictionary. I'm going to actually pop out that entry of the current key. I'm going to pop it out of the dictionary. I'm going to set the value to the current so I can access it, but it's no longer going to be in the dictionary. Okay? And this is really important because it's going to save us a lot of time. If you can imagine this whole big bag with a bunch of locations, I can take the first location, I can compare it to all the other locations, right? Once I've made that comparison, I want to throw that value out. I want to throw that location out because I only need to work one direction. Okay, once I know all the things this is connected to, I don't need every other place to look at that again. So what's going to happen is the first location is going to take the longest time to process, but it's going to take faster and faster. So as we pull these things out and compare it to everything else, the bag is getting smaller and smaller. Right? So that's the second. This is the real value of the pop command. Okay, but pop will get rid of things in a dictionary list, but it'll also set it to something. So this is a kind of 2-in-1. I take the data, I can work with it now as this variable, but also it has left the dictionary. I'm going to take my new match dictionary. I'm going to create a new entry in that dictionary and call it my key. Right? So key right now is the place ID that I'm looking at, and just like before, I'm going to make a new key in my match dictionary. It's going to be the name of that place, or the place ID. I'm going to set that to an empty dictionary. So now I have the information about this current location, and I want to look through all the users at that location. Okay, so I'm going to say for user ID in current, and current is all the data about the current POID, and in that data somewhere is the array of all the user IDs. Alright, so I've just accessed now this array. I'm going to cycle through every user in that array. It's going to get a little bit intense in terms of all the sort of digging into these things we're going to do, but just try to stay with it. You can re-look at this again later. So now once I have every user ID, I'm going to look through every other place in that bag of places. Right? So I popped the first one out, I'm looking at all of its users. I'm going to now iterate in another loop over all the other locations that are left in the bag. So I'm going to say for ref in POI dictionary. Alright, so now this is the dictionary that we're using, but this first one is no longer in that dictionary, right? We popped it out. So this is just all the other ones that are still left in there. And those are those are my reference locations. And now I'm going to look through all of the user IDs in each reference location and seeing if this user ID, which I'm currently working on, matches any of those. Okay? Let's say if UID, this is this one, of the current place, is in the dictionary in the entry for this reference location in its UID array. And if that happens, we have a match, right? And for now, just to troubleshoot, I'm going to say print match found. And I have all the references now to what this match means, right? Because I have the reference to the current POID and the key that I'm iterating over. I have the reference to, I have the POID of the reference place I'm looking at here. I have the user ID that I'm looking at here. All right, so I can just write out some notes for myself, say match found between key and reference. Let's make sure this works. Okay, so it's finding all these matches. You can see this is the current key, right? You see they're grouped. And for each of those, it's going over all the users and seeing if any of those users match any of the other users in all the other locations. This takes a long time. Okay, and this is why it's really important that we narrow down only the data we're interested in, because once we start to do these nested loops, it's going to search over each location twice, right? So it becomes a combinatorial kind of problem. This is also why it's important to pop it out, because as you go deeper and deeper into the bag, the list of things that's compared to gets smaller and smaller and smaller. Another thing that takes forever is printing everything out. So I'm going to stop this. You never have to do this, just to show you and make sure it's working. I'm just going to restart Python. So I never need to really print this after I already know it's working. All right, and now I just want to build my dictionary in such a way that I have not only data about what's connected to what, but I have some kind of weight, right? So every time it finds a match, I don't want to just store that match, right? So here I have this key that's in this dictionary. I have this empty dictionary. In this dictionary, I want to put as a key every other place that this place is linked to, and as the value for that key, I want the weight. Okay, and the weight is going to be the number of times that it's connected. So every time it finds this connection, it's going to increment that weight. The first time it's going to have 1. If it finds this connection again, it's going to add another link. Okay, and that's just, there's no rule for this. It's just however you want to set up your dictionaries. What I'm going to do is say, if the reference, so now it's found a link, a connection here, right? And the reference is the POID that's connected to. So if the reference is already in the dictionary, okay, so we're using the same kind of in function, saying if this reference is already stored in this portion of the dictionary, I'm going to increment the value that's stored there. Okay, so in the dictionary under key will be another dictionary which for every reference is going to have a value. Okay, and if it's not already stored, so this is the first time I found the link, it's going to actually set that value, to 1. Alright, so I'm going to run through this. And the structure I want here in this match dictionary is I just want a list of all the places that are connected to other places, and I want to have some kind of weight to it. Okay, and that's what I'm going to visualize in GIS. Every link will be a connection between 2 places, and that line will actually have data about how many times that connection happened. So I can analyze somehow the strength of those connections. Okay, so here it's finished. This is just a printout of the length of our dictionary. I'm just going to implement a little bit of code to keep track of the progress of building a dictionary. In these kind of cases, this code can take a while, and it helps to put in some print statements to monitor the progress so you know if things are progressing. So in this case, we know there's 12,000 records that has to go through, and here in the bigger for loop structure, it's going through every key in the dictionary, right, of which there's 12,000 entries. So I'm just going to put in a bit of code here as it's going through the dictionary to check where it is in the dictionary, and then print out something every time it processes a certain amount of information. So you don't want to print something every piece of information, because those print statements actually use up time and make your scripts run faster. But you can put in something so it prints, say, every 1,000 records. Okay, so what I'm going to say is if length of match dictionary, so as I'm going through, I'm building up this match dictionary and adding records to the match dictionary. I'm going to check the length of that dictionary every iteration of the loop. I'm going to say if length of match dictionary modulus 1,000 equals to 0. So if you don't know what modulus is, basically this returns the leftover or the remainder after a division. So you take the length and divide it by 1,000, and then the modulus will return the remainder. So if the remainder is 0, it means that I divide it evenly into 1,000. So every time it reaches a multiple of 1,000, this is going to become true. And if that's true, we're going to print the length of the match dictionary. Okay, so this code is very basic. It'll just print where it is in the dictionary as it's going through 12,000 results, and each time it crosses 1,000 results, it's going to print out how long the match dictionary is currently. And that's just so we can keep a track, or that's just so we can keep track of where we are in the process. Okay, and once this process is done, I'm just going to dump out another pickle file to store that dictionary. And this is the same as before. I'm just going to take this code from our previous script. And this is just because this takes a while. I don't want to have to rerun this every time when I when I want to process this data, I don't want to have to rerun the script every single time. So I imported pickle already above. Here I loaded the pickle file. I'm just going to dump out another pickle file for this match dictionary. And I'm going to put it into the same directory and just call it match dictionary.p and then hit run. So you see here, as the script is running, it's going to tell you every time it crosses 1,000 results based on this couple lines of code. And because it's popping the current key off the list every time, the first 1,000 is going to take the longest. And as it goes, the amount of other reference locations it's checking gets smaller and smaller and smaller. So this is going to go faster towards the end. But it's good to have this kind of printout so you can see the progress, make sure everything's running okay. So once the process finishes, we can go to our browser. And here's our match dictionary.p pickle file, and we can see that it has the size and everything processed okay.